Okay, let's take a look at the next function. Here we have y equals -2 plus cosecant of the quantity 1/2 x minus pi over 3. So we'll start with the amplitude again, and the amplitude is 1 because the coefficient of cosecant is just a 1. There's always an amplitude and there's always a period, regardless of whether it seems like there's nothing there in particular. So you always have to establish what those are. So now the period. Well, we know that the period is 2 pi for the sine, cosine, secant, and cosecant functions, and we're going to put that over the coefficient of x, so that's over 1/2, and that makes 4 pi. So for right now, this graph is going from 0 to 4 pi. Put that down at the bottom, 0 to 4 pi. But we know that that's going to change because obviously there's a horizontal shift. All right, now let's find that horizontal shift. So I take the 1/2 x minus pi over 3, set it equal to 0, and solve for x, and we get x is equal to 2 pi over 3. So that's a positive 2 pi over 3. So again, we're going to shift to the right. I'm going to take that out so that we have space to graph. All right. And then the vertical shift. There's a -2 added to that cosecant function, so that's going to be a shift down of 2. Since we're looking at the cosecant function, I'm going to graph the sine function and then base my cosecant function off of that sine graph. So y equals -2 plus sine of 1/2 x minus pi over 3. Let's see, so we've got an amplitude of 1 and a period of 4 pi. And we know that our horizontal shift is moving to the right. So I don't have to worry about the left-hand side of the graph. The amplitude is 1. That tells me that we have basically our regular amplitude, but we have a vertical shift down too. So that means that whereas normally we have the center of the graph, vertically speaking, is along the x-axis, but now that's going to be shifted down 2 units, and so that x-axis, or the center of the graph, is going to be shifted down. So I'm going to start this one over again, and I'm going to make space on the bottom and not worry so much about the top having space. So let's do this. All right. So let's see. So we said we normally go from 0 to 4 pi, but we're adding 2 pi over 3 to those values. So now we're going to go from 2 pi over 3, because I just added that to 0, you get the same thing, 2, and what's 4 pi plus 2 pi over 3, helps to write it out sometimes, so that's 12 pi over 3 plus 2 pi over 3, and that's going to give me 14 pi over 3. All right, so we start off at 2 pi over 3, and we're going to end at 14 pi over 3. And what's halfway in the middle? So if I add those and divide by 2, the two endpoints, 2 pi over 3 plus 14 pi over 3 gives me 16 pi over 3. Divide that by 2 and you've got 8 pi over 3. That's the easiest way to find the middle. And then I can do the same thing with the 2 pi over 3 and the 8 pi over 3. Add those together, you get 10 pi over 3. Half of that is 5 pi over 3. And the middle here would be, let's see, 22 pi over 3, so that's 11 pi over 3. So now I've got those marks. And I know that my graph is shifted down 2 units. So here, I'll mark that in green, is my middle. Keep track of that. All right. And we know the amplitude is 1. So we want to go from, let's see, -3 to -1. We've got a -2 in the middle of those. All right, so now we're ready to graph the sine function. And we start in the middle on that kind of imaginary axis, if you want to think of it that way. So I'm kind of imagining that this green line is my x-axis. And then we go up, kind of interferes with the numbers, and then back to the middle, and then down, and then back to the middle. So we get our regular sine graph. Okay. Now, we said before that whenever you see an x-intercept, that's where you have an asymptote. We don't have any x-intercepts here, but we're still going to have asymptotes. So what I do is I look at, well, if we hadn't shifted vertically, what would have been the x-intercepts? So that still works. So we still have those 3 asymptotes. So up here at the top, now, I can draw my real cosecant graph. So I'll label the y-axis, and then label the x-axis. Oops, you know what I'm going to do is put it on the top. So 2 pi over 3, 5 pi over 3, 8 pi over 3, 11, and 14. Okay. And let's put in our asymptotes, which is at 2 pi over 3. That's coming down. 8 pi over 3 and 14 pi over 3. And now I'll graph the function in blue. So I have this 5 pi over 3 is at -1. Put that point in, and then I go up from there. And then I put in this point from 11 pi over 3. That should be roughly here. And we go down from there. And there's one complete cycle of the cosecant function.